Hello and welcome to this video. In this video we're going to be talking about how to put batteries in series and in parallel. So we've already looked at how we'd add the total resistances of something if we add the resistors in parallel versus in series. Now let's have a look if we put batteries in series with each other or in parallel with each other. How is that actually going to make a difference? So what I mean by putting a battery in series or in parallel with each other is, let's say I had a cell here, and then I decide I want to put another cell in series with it. They both have an EMF of epsilon. What is the total EMF of the system? How do we add batteries in series? And the way we would do that, if you think of these as charging stations, essentially we're going to charge up the electrons here, and then they're going to charge up even more when we get to the next one. So our total EMF, so E total, is just going to be the sum of all of these EMFs. Okay, so that's because all of the electrons still have to travel through both of these things because they're being placed in series. So they're just going to keep charging with more and more energy. So if we wanted to make a really high voltage thing, we would put maybe 3 or 4 batteries all in series with each other. This is why some appliances that you'll get will actually need 3 or 4 batteries to be able to work. Now, these batteries aren't always going to be placed in series. Sometimes they're placed in parallel. And if they're placed in series, the idea behind placing them in series is we want a higher energy. So we need a higher potential in order to make those things work, is essentially what we're trying to get at. So you'll tend to see that if you need bigger batteries, it tends to be bigger electrical equipment. So like, again, a battery for like a remote might be like a AA battery. Battery for a car is going to be much, much bigger. Okay, but now what about if we had a combination of batteries that we actually add in parallel with each other? Both of these batteries will have an EMF of epsilon, but what would be the total EMF of this combination in parallel? And again, our approach to this has to always be to trace the path of the electrons. If we trace what path the electrons take, it's going to make everything a little bit easier to be able to problem solve. So the electrons coming in here are going to be split at this junction, and they can either go up here or down here, but they can't go through both. Okay, so the electrons can only be charged by one of these or the other. And so this means that if we have two things with the same EMF, their total EMF is just equal to one of their EMFs. Okay, so the total EMF total is just equal to one of their EMFs, because all of the electrons are only traveling through one of these things, so they'll only be charged up with the EMF of one battery. Okay, now the reason we use these, because we clearly aren't getting in a higher potential, but if we split the amount of energy that's being lost from each of these batteries, they'll both last longer. Okay, so the point of putting things in parallel like this is that we'll have like a half and half split between the electrons. So it means that the amount of energy stored in the battery that's going to be transferred to that electrons is going to take twice as long, because we're putting through half the amount of electrons that we would if it was by itself. So if it was by itself, we might have, let's say, 10 electrons coming through. Obviously this is a ridiculously small number for electrons, but just as an example, all 10 electrons have to go through here, and they will all take some of that energy, depleting that energy stored in the battery. Whereas in here, if we have 10 electrons coming in, we'll have 5 going up here and 5 coming down here, which means that only 5 of them will deplete it per second. Okay, meaning that if we have less electrons that are depleting it, we have more time that it's going to take for it to deplete. So our battery lasts longer. This is essentially all you need to know for batteries. So this is going to be quite a short video. And this is the basics. So we just need to know that in series, we use that to get higher potentials because we're going to get more energy. And in parallel, we're just going to get the same EMF, but the battery will last longer. One fair warning before I end this video is to be careful in the questions about this. Very often when they're asking you to sum these potentials, they might draw something that looks deceivingly like this, but they might actually draw two batteries that are actually opposite to each other and then ask you what's the total EMF of that battery. Now notice these long ones are the positive terminal of the battery and the short is the negative terminal. So if we've got a negative terminal here, they're going to lose energy by going through this because they're going through it the wrong way. So let's say they told you that the EMF of this was 10 volts and the EMF of this was 5 volts, then the total EMF of this battery is actually just 5 volts, okay? Because it's just going to be the difference because they're going to get charged up by 10 volts here and then lose 10 volts across here, okay? So just be careful of that and make sure you're getting all your batteries drawn the right way around. Thank you for watching.